Okay. Okay, when I left off, I was in the process of, well, let's just, let me bring up notes for this stream. Sound cancellation, identification, we're done with indices, and since indices can be reused, we would like to move to a system where sounds are identified by their playback, a serial number. So once a sound is canceled or it's complete playing, that playback ID is no longer valid. And in the notes, which are in the description, the link is in the description, I describe basically what I'm doing here. And last night when left off was in the process of looking at all of these 14 functions in sound.c, making sure that or converting them over to the new system. Let's take another look. Okay. So we left off with check call fail. So this is a function whose purpose is to look at the return code from a Miniaudio API call, and if it's not what's expected, then set some error information, including a global flag indicating that the call failed. And so we're going, so on our little checklist over here, let's zoom in here. Checklist here, that has been converted. Sound find available slot. Okay, so a slot is really all a slot is an index in, well, it is an entry in this array here, G sound list, which is 25 list of size 25 of this structure here, which is described in the Livestream notes, which is linked to in the description. So let's go through this. Also, when I left off, I decided that instead of using uint32, instead of naming identifiers, playback IDs, as uint32s, We'll just give an alias, playback ID, T. And so this function, what it does, Control X, Control minus there. What this function does is it looks for an available slot in G sound list. That's an array that stores Miniaudio decoder and device information. We look for an available slot. If we find one, mark it as unavailable, and we return a playback ID, which, as I mentioned yesterday, is just an index and a playback serial number smashed together into a 32-bit. And while I'm here, I can only answer questions in chat which are related to this live stream. Thank you. Let's get rid of that. Okay. So it's just simple linear search. We initially assumed there's a special error code. So these playback IDs, they do double duty as error codes or identifiers. Well, they do triple duty. They are error codes. They are serial numbers for the serial number of the sound being played back, and they also store indices. And why are they all smashed together? It's because I don't know of a good way to return multiple values to Lisp in CFFI. And I do not want to use pointers. So we'll just do it this way for now. You can read about this. I explained it in detail yesterday, but this is a value here, and this is a value here, and this is what a playback ID is, and it's 32-bit. In the future, I may use bit fields. Nobody really has anything good to say about bit fields other than you don't assume anything about them. And so in Lisp, let's go down. Here's an example of how this a typical usage right here. So we get a playback ID. This is in Lisp. We get a playback ID by calling, say, sound file async. And we have to know to get the this flag, this test for error condition. But if we want to get the serial number, we need to know how big these things are, and also when we type def them in CFFI. For instance, let me find a good example. Maybe here. I don't. It's been a while since I've. Well, CFFI has to know what it's, the size of what it's seeing from a C call. If we use bit fields, that's harder to manage than just explicitly saying that a playback ID is 32 bits unsigned. So for now, we'll avoid bit fields. But if I think if we can always guarantee that they're uint32t sized, 4 bytes. I say they're worth using, but I don't know of any way to guarantee that a bit field struct is a certain number of bytes. We can try. Let's try it in the spirit of experimentation, and let's try it, because it would make this. It would just remove a lot of. Let's try it. And I have used bit fields, I think, once in my life. And that's going all the way back to, I don't even want to say when. Long time ago. Oh, yes. 1 hour. Or close to it. That's how long I'll keep the stream going. It's locally in Pacific Standard Time, or is it daylight time? On the West Coast, in USA, it's about 2:30. 14:30. Okay, so let's go to CPP ref. Tiny little text box. Bit fields. Okay. Identifier and size. I don't know what this is. This is C++ stuff, and I'm not ever using C++ if I can help it. Example, unsigned. Can we do, well, okay. 3-bit unsigned field allowed values are 0 through 7. All right. So you just put a colon and a number of bits. Let's try it. Type def struct. We'll call it what. So let's see. Let's look at our definition for. Look at our bit layout. It's we'll call it index or error flag, and we'll call it serial or error code. And the first one will be 6. That's the index, and the next one, this one will be 26. And we don't care the order. Although it would, if it would be, I believe in C, it's required that struct members have a memory layout which obeys the ordering that they are defined in, that they are listed in the struct. So in other words, if you have int a, int, and that means that in memory, member A must precede member B, must precede member C, and they'd be they're possibly padded for alignment. Okay, so we're going to call this, okay, and all I'm doing here is I just want to see how big this is. So we're going to call this uint 8t, and we're going to call it very long name, and then uint 32. Why don't we, oh. 63. We actually have, okay, so allowable values. Well, I'm not going to, it's just arithmetic. So if this is a serial, I'm sorry, not serial. This is index. This is index into the global resource list. If it's an index, there's one value that cannot be used, and that's all ones, and that's 63. So we have 0 through 62. So we have, yeah, max index is 62. I don't like calling this uint 30, uint 8. It's very misleading, so we'll call it unsigned. And this is going to be in P. We'll just let that go like that. And normally I like to prefix my members with some sort of mnemonic string, maybe like PBID for playback ID. Things get a little long-winded. That way, the reason is when I use the abbreviation or expand. So I just type the prefix and I can cycle through them. All the members. This is before LSP was on the scene in Emacs. So we'll call this wouldn't it be nice if we could do this? If this could be like a union, we say that. Can we do this? This is okay. Yeah, let's do this. It's much better. Unsigned. Let's see if the compiler chokes on this. Unsigned. We will call this index, and that will be 6 bits. So what I'm getting at is, since these 6 bits do double duty, they're really, instead of putting like, it's giving the member a name like, oh, it's this or this, why not just use a union? I don't even, well, we'll just experiment here. I don't even know if this is legal. I'm not going to look it up either. I'm just going to let the compiler complain. Is anybody watching and they know the answer? Let me know. It's very possible that there's some edge case that language designers are aware of that I'm not, and so it's illegal. It's called serial N for number. That's 26. And this would be error code. Okay. All I'm going to do is assign some values and print things out. We won't use an initializer. PB dot $63. Let's write a little function to print these. I'm okay with, yes, even though it's a struct, we hope it's 32 bits. So that's the first thing. Oh yeah, that was the whole point. Printf okay, and now we'll write a little function to print these out, just because. What was the error code again? The error flag was hex 3F. Okay. I'm going to call it error flag. And we're going to get rid of that. I'll just do this. Well, let's see if this works. If you can put bit fields in a union, something in my dim past memory tells me that you can't. Well, let's see what K&R has to say about it. Bit fields. Should we go to the informal or should we go to the definition? So let's see, page, bit field declaration, 212. Let's go to 212. This is the more formal. In the front of the book, there's an informal tutorial style discussion or definition or description, and then in the back there's a more formal 212. So we'll go to the formal. 212. Let's see. We need light. Might get a little bright. Okay. Well, let's see what CPP ref, because it's they don't have anything to say about it. Well, then let's just compile this thing and see what the compiler has to say. Is it LU? Maybe the type specifier is LU, but certainly didn't complain so far about our bit fields. And maybe, just maybe, I might move the code to use that. Is it LU? I can't remember. I think it's LU. Unsigned law. Okay. Yeah. Okay. Size of is 8. Well, that really sucks. It should be 4. 32 bits. Is there a way to clang? Now I'm going to go to the internet and ask. Why on earth is it 8 bytes? It's double what it needs. Okay. Who is this? I think there's a pragma. There's a pragma to pack Okay, I'm not going through all of this. Clang, pragma, I get Objective C. The Lost Art of Structure Packing by this guy. The thing to know about bit fields, they're implemented with word and byte level mask and rotate instructions, operating machine words that cannot cross word boundaries. Okay, I want to Pragma Pact. Let's see if this is issues. I'm just going to assume. I'm pretty sure that okay. This is GNU C MSVC Pragma. Begin. Okay. Do I have the? Okay, let's go to Google. It's good stuff to know. But at the very least, it means that I can't rely on this. But if we can pack it into 4 bytes, that's just absurd, because this would be 1 byte, right? I mean, even if it aligned on byte boundaries. Even if it aligned on byte size boundaries, this would be 1, and then this would be another 4, 6, 5 bytes, 6. So a bit, how to declare a packed struct. I'm not going to go to Stack Overflow. Okay, this is Clang LLVM, so I guess this is right out of the horse's mouth. What is this? Altera struct pack align? What's Altera? What is this? Okay. Pragma. Okay, how about Clang Pragmas? Pragma pack. Microsoft extensions. Is there a list of pragmas? So for those of you who don't write code, this is this is the bread and butter of development, is trying to find something simple and wasting your time. I don't know what ti.com. I don't know which Clang compiler user manual. Okay, didn't I just look at this? Pragma. surely there should be a list of okay, this is GNU, this is GCC, and Clang basically is a superset of GCC. Pragma Pack simply sets the new alignment. For compatibility with Win32, GCC supports a set of pragmas directives which change the maximum alignment of structures, unions, and classes defined thereafter. The end value is always required to be a small power of 2 and specifies the new alignment in bytes. Why don't we just say Pragma Pack 1? Compile. Five, just like I said. Okay. So if we say 2, okay, this is it's going to be padded out. So this wait, did I say 5? It should be this is 3 bytes. It should be 4. Well, let's think about this. This is 1 byte. And then this is 4 bytes. No, yeah. Where am I going wrong here? Well, I'm going wrong is because the members are aligned on at least byte boundaries, and so you can't have this actually takes up, this is 6, 7, 8. So there's an extra 2 here, that 2 bits that aren't used, and then the 26 over here get moved over. So yeah, I'm not using bit fields. There's just, I don't like them. It's too difficult to know what the compiler is going to give you, even if you pack. And so if I return, okay, so let's think about this. So let's go back to sound.c, which is where all this got started. So I'll expand that in a minute. Let's go down to a function that returns one of these right here. I have to know in Lisp, I have to basically create an alias for this playback IDT if I'm using, well, whether I'm using a struct or whatever. Right now, I know what that is an alias for. It's an alias for uint32. I'm doing all the packing and unpacking. Excuse me. But if I use this, say, now it's what? It's uint 64, I guess. too much to deal with. Too much. I don't know if it would really save me any effort overall. So if we look over here, these are these functions starting from here all the way down to here, which isn't much. This is where all the packing and unpacking happens. Excuse me, one moment. I just need a little more light in here. So, we will not take the bit field approach. As easy as they are to use in C, I don't know exactly what I'm going to get on the other end. CFFI, if I return one of these, is it going to be 64? Is it going to be, it's not going to be 32. Who knows? Okay, I really would like to test these now that I think about it. And if I meander a little bit, sorry. I would like to take a slight diversion and test this. Even though it so let's we're going to call it bit field test, but there are bit fields. So we're just going to pull that code in here. Do a little testing so that I can proceed with confidence. When I get back to what I started with, and what I started with was converting functions to use these playback IDs. So there we are. So let's, and we have the error codes. Let's first see if the compiler likes this. What do you know? All right, so all those bit mashing functions the compiler is just fine with. Okay, so let's, we need, first thing we need is we need a function to print these things. So we'll just say print playback ID. Now it won't be the same, obviously, as what we had. We're not using bit fields where you have to extract everything. So we should have a function somewhere saying this is an error. Yes, SND is error. we should use. Like so. And again, like so. And once more, like so. We're just going to print out, well, no, we'll print out text for the error code. Which unfortunately is just going to have to be a giant case statement. Okay, so SND, get the index, and then SND, get serial, that's it. Okay, so let's see. Let's try a simple case. There's a function here, make playback ID. So let's just, okay, so make playback ID, and then there'll be a make error ID later. Okay, so one moment. Unfortunately, the real world interrupts me sometimes. Okay, so SND, oops. And we'll just say the index is 12. Now, what are you complaining about? Error code. Oh, well, yeah, we should probably write that, huh? And right now, the only error codes we have are these. What is it, Alt-W? I'm talking to myself, sorry. And so here, the way I've set this up is on the error codes, I just include the error flag. So I include these 3 1 bits, which signals an error condition, as part of the error code itself. So I don't have to unpack the 26 bits for the actual code. Okay. I can do this the right way, or I can do it. Okay. Copy region is multi-line text. So I'm using CUA column mode. I don't want to kill as multi-line text. I want to copy as multi-line text. Meta M, Alt M. Go down here. There we go. And then, well, I could have done this, huh? Oh, it won't let you press return. Okay. I'd use a macro if I had a lot of these. And yeah, I definitely would have used a macro, because then I would, if I wrote a macro for this, I'd copy this text here, go down, type, insert printf, and go to the next line, all that sort of thing. We'll just do it. We'll do it the dumb way. Because we only have a few of these. And Non-void function does not return a value. Which one? Oh. Oh. Okay. Might be another, yeah, there. Okay, test it really quickly. Index 12, serial 0. Let's set the serial number to something more interesting. Initialize it. Well, let's do this. Let's just let's call this multiple times. Whatever. Did you mean static? Maybe. $1264, 128. Oh, now we're in trouble. What does this mean? No, error, invalid. What? Huh? Okay, so we have to do a little bit of debugging, and we're running out of time. Which is exactly why I wanted to take a look at this stuff. Not hard stuff, but I wrote it in a hurry. So the serial number, let's look at the get serial function. I believe serial numbers, let's think about this. So let me bring up, I'm going to use a non-Emacs calculator. And I know that's so the first one, the first thing, the first serial number, let's go over here. Very carefully, there. Okay, the first serial, let's see, index 12, serial 0. Then we went all the way to 64. And then we went to 128, double that. And then this is not what we wanted at all. Okay, so we should have a little way to print out the binary for these. So here's how we're going to do it. For 0 between 0 and I is less than 6. And we're going to print this out in little endian form because I really don't want to mess around with so in other words, even though these are the least significant bits, they're not going to be printed over here on the other side. They'll be printed on the left, so it'll be little endian form. And so this is really easy. If and 1 I'm going to hope that the so-called ternary operator has a lower precedence than AND, but then again, this is C, and they have decided a crazy set of rules when it comes to bitwise operators. The ternary conditional. Ternary conditional is better name than ternary operator. Ternary conditional, lower priority. And I guess at the bottom of the loop, let's just put it right in the loop. We'll just say div equals 2. Right, that's shifting it right one bit. Separate everything with space. Between 0 and 26. Same deal here, same loop. And so let's just well, of course, Mr. Fisher, because 63 just plain ain't allowed. Otherwise, everything looks really, really cool. 62. Yeah. Notice the serial number doesn't go 0, 1, 2, 3. The serial number, it's just an ID. And so it's just an ID that is unique. So these, like I've been explaining, these 6 bits are the index into the array of resources, Miniaudio, and then this is just a unique identifier right here. And this just gets incremented by 1. But what I call a serial, when I say get serial, I include the index, because there's no point in all that shifting and masking. It's not needed. It's just I need a number that's unique for a particular index. And so the index here is always fixed, you know, for playback, and what changes is this serial number. Okay, so I didn't test everything. I guess the next stream we'll finish testing this bit bashing stuff for error conditions or for error codes. I guess we can do that now. PB ID equals. Let's just say E sound, which means error in sound playback or whatever. SND what? We'll do that one. Compile to XB. Okay. I mean, you know, 5 test cases. It's kind of difficult to get this stuff wrong in any serious sense. Okay. That puts us at an hour. Thanks for listening. And as I said before, you can view the notes for this live stream and the previous live stream. There's a link in the description, and credit for the software, Miniaudio software, and some of the sounds that I'm using. Once again, thank you.